Hi guys, hope you're having a great day. I'm here again to talk about slope. We've been talking about slope and what the definition of slope is, and now we're really getting into how we calculate slope. So we looked at how to calculate slope from a graph, right? We use rise over run, or we could use that slope formula, change in y, change in x. There's a couple ways that you can find slope. By now I hope that you're figuring out which one is the easiest for you and which one that you like to use. Today we're not looking at any graphs. We're actually determining slope when we are given 2 points. So I'm going to tell you those two ordered pairs and you have to find the slope between those. Remember that when we are talking about slope, I'm going to write it here for us. When we are talking about slope, we are talking about the steepness of a line, right? How steep that line is. Now remember, I'm just giving you 2 points, but if I give you an ordered pair like 2, 3, and 5, 7, right? If I give you 2 points, those 2 points can make a line. So if we had a coordinate grid, you could actually plot those 2 points on a coordinate grid, right? I could say 2, 3. That point is at 2 on the x and then 3 up. So that point maybe is about right there. Remember, this is just estimation. And this point 5, 7, I would go over 5 and go up 7, maybe is about right there. Those 2 points that I gave you, if you connect them, they create a line. Ooh, that line is a little bit crooked, but you get what I'm saying, right? The points create a line, and you could tell me how steep that line is. It's just another way to give it to you. Instead of giving you the picture, I'm giving you the points. All right, so we're going to go ahead and jump right in and go ahead and get started. Here is our slope formula, and we're going to make sure that we have that down and that we understand it. So again, I'm going to give you 2 points for an example. What if I gave you the point -5, comma, -2, and then the other point I give you is 6, comma, 8. So I gave you those 2 points. We have to know how to label those points in order to use this formula. Inside of this point, this first ordered pair, I have an x and I have a y. I have an x in this coordinate and a y in this coordinate. Right? So I have x and y pieces in both. However, in your formula, you see there's x's and y's, but there's also like x1, x2, y1, y2. So I'm going to label my points and say this point right here is my first point. So that's the x1 and that's the y1. This is my second point, so I'm going to label that x2 and y2. If you had a third point, you would label it x3, y3, but in this case, we only need 2 points for this formula. So I'm going to write out the formula again, or I'm going to draw my line and we're going to fill out the formula. We're going to substitute our values in, okay? So I'm going to look for this number, the y2, and I'm going to try to color code this as best as possible to help you see it. The y2, I look at my points and I say, hey, the y2 is right here. It is 8, so that means I'm going to put 8 right there. Then there is a minus sign already in that equation, so I have to bring the minus sign down. Then I'm going to look for my y1, and that y1 is right here, and that y1 is a -2, so I have to write -2. I'm going to look at the bottom now, and I'm looking for an x2. My x2 is way over here in this point, and it's a 6, so I'm going to bring that into my formula. And then again, there is a minus sign in that formula, so I have to write that minus sign. And then lastly, I'm looking for the x1, and the x1 is right here. It is -5, and I can bring that into my formula. So now that we've brought everything into the formula, it's time to do some math and do some calculations. I do my calculations straight across the top and then straight across the bottom. So if I'm looking at this top, it says 8 minus -2. 8 minus -2. Now you could type that in your calculator, but I like to know that when there is a double negative right here, minus negative, I just change it to a big old plus sign. So really across the top, I could say 8 plus 2, and that makes it whole much easier. 8 plus 2 is 10. And then across the bottom, again, I see this double negative. I'm going to circle it. I see a big old plus sign. 6 plus 5 is 11. Can I simplify this fraction any? Can 10 and 11 both be divided by the same number? Nope. So that is my answer. My answer is 10 over 11. Meaning, let's talk about the meaning of that. If I were to graph these 2 points, the first point is -5, -2. So I go over -5 and down -2. And then the next one is at 6, 8. So I go over 6 and then go up 8. And if I were to connect those 2 points with a line, the slope of that line, or the steepness of that line, is 10 over 11. And remember, we know that slope is the same thing as rise over run. I'm going to use another color, right? We love colors. This rise over the run. So if you were looking at this line, you could rise 10 and run 11. Right? Maybe it's a little off. This was just estimate, right? Quick sketches. But the rise of a run would be 10 and 11. So you could do 2 things. If you're saying, man, I don't get this formula at all, you can make a picture every single time, but you're going to have to draw that coordinate grid absolutely correct, right? Maybe you have some grid paper laying around and you can plot those 2 points and draw that. Maybe you'll have to draw your own graph. I like to know how to use this slope formula because I can just do those calculations and figure out what my slope is. Okay, we're going to be using this slope formula throughout these next couple examples. I'm going to go ahead and click us to our first one. Our first one says, find the slope given the following points. And there's 2 points there. So since there's 2 points, I'm going to label them, right? This is the x part, the y part, and this is my first point. So I'm going to say this is the x1, the y1. This is a second point here, and it has an x part and a y part. So I'm going to label it x2, y2, because that is the second point there. I'm always going to write out my formula, guys. I want you writing this formula every single question. The more times that you write this formula, the better it will be committed to your memory, right? It's one of those things that you will just remember. y2 minus y1 over x2 minus x1. So let's substitute those values that we know. We know what y2 is. y2 is 5 minus, we know what y1 is. I look right here with y1. It is -1. Remember, I have to bring the minus in, and it's a -1. x2 is 15 minus x1 is 0. I'm going to do my math. Oh, I see that there is that double negative there, right? This double negative, I can circle it, and I like to change it to a big old plus sign. It makes my math so much easier because I like to do addition. 5 plus 1 is 6. 15 minus 0, well, that's easy. 15 minus 0 is still 15. And then we see, can we simplify this fraction? Can both of these be divided by the same thing? And if you're not knowing what I'm talking about here, I'm going to do a quick little sketch of my imagination of what's happening. I take the number 6 and I say, 1 times 6 is 6. 2 times 3 is 6. And that's all my factors of 6. But then I have 15, right? You made these T-charts back in elementary school, whether you remember it or not. And you said 15. 1 times 15. 3 times 5. And that's it. And then you looked at those T-charts and you said, what numbers do they have in common? They both have a 1, but I'm not going to pick 1. I'm going to pick 3 because they have that in common and it's bigger than 1, right? So I call that something called the greatest common factor. That's what you are doing there, and that's what I'm doing when I say, can both of these be divided by the same thing to simplify this fraction? Greatest common factor, sometimes people refer to that as GCF for short, right? So we are going to be able to divide both of these by 3, which means 6 divided by 3 is 2, and 15 divided by 3 is 5. So my final slope is 2 over 5. That's my answer here, 2 over 5. And again, if you don't like this slope formula, if you want to make a graph and graph those 2 points, if you want to graph 0, -1 right there, and if you want to graph 15, 5 way up here, and you draw that line, you could calculate your slope with rise over run. So we're going to go ahead and move on to our next example. I'm going to clear this screen for us, and then we're going to move on to our next one. It's another 2 points. So this one says find the slope given the following 2 points, -2, 7 and -6, 1. Again, we're going to label these points, right? There's an x part, a y part, and both of these are in point 1. An x part, a y part, and both of these are in point 2. So now that we've labeled, we're always going to write that formula. So m equals y2 minus y1 over x2 minus x1. And we have all of those parts to fill into this formula. So I'm going to fill them in. Y2, I look back over here and my y2 is a 1 minus y1 is a 7, x2 is a -6, minus x1 is a -2. So now I'm ready to do these calculations. I'm going to do it straight across the top. 1 minus 7. If you have 1 and then you subtract 7, that puts you all the way at -6. Then at the bottom, oh, I see a double negative there. So I'm going to grab a different color and I'm going to circle that double negative and make it into that big old plus. So now let's read what that says across the bottom. Now it's asking me to do -6 plus 2. It's still a -6. So -6 plus 2 only puts me at -4. So then we ask ourselves, can we simplify this fraction? Remember, I did that thing called GCF last time. I'm going to make sure I make those T-charts if you need to. Some of you can already know what the GCF is just by looking at the numbers, right? And that's so awesome that you do. So 6, I'm going to put 1 times 6, 2 times 3. For 4 is 1 times 4, 2 times 2. Oh, and I see, oh, both of these have the 2, so I know that that is what I can divide both of these by to simplify that fraction. So -6 divided by 2 is -3. -4 divided by 2 is -2. And then there's one more thing. Can I leave a negative over a negative? Not really. A negative over a negative is a positive, right? Negative divided by negative is a positive. So I have to change this just a little bit. My answer is positive 3 over 2. Since it was a negative over negative, it cancels out. My slope, my final answer is 3 over 2. And again, just to prove my point that a negative over a negative is a positive, if you wanted to make a quick sketch of these 2 points, right? And I recommend that. -2, 7. I go to -2 and all the way up 7. And then I make another point at -6, so -6, 1. If you made that quick sketch and you connect those 2 points, what type of slope is that line? Is that a negative slope or is that a positive slope? It's going up. This is a positive slope. So it makes sense that my answer is a positive. If you ever have concern about those positives and negatives, draw that quick picture and see, is it a positive slope or a negative slope? In this case, my picture told me a positive slope, so I knew that my answer of positive 3 over 2 was correct. So just to sum that up, right, we labeled our points, we filled it into our formula, we simplified by finding the greatest common factor and we divided by that greatest common factor, but then we noticed that a negative and a negative, we can't leave it like that, so we changed our answer to a positive. And if we got confused with all those negative over a negative, I drew a picture of those 2 points, connected them, and I saw that that graph has a positive slope, so I know that my answer needs to be a positive answer. I'm going to go ahead and erase this. I believe we have one more question on our notes here to do together, and it is this one. Find the slope given the following points, 5, 2, and -10, -3. Again, I'm going to label these points, x part, a y part, and these are both point 1, x and a y, and these are for point 2. We've labeled, we're going to write out our formula, m equals y2 minus y1 over x2 minus x1. And we're going to substitute what we know. So I'm going to fill it in. Y2 is negative 3 minus y1 is 2. X2 is negative 10 minus x1 is 5. And I'm going to do my math. Negative 3 minus 2. If you're at negative 3 on a number line and you're subtracting 2 more, you're going even more negative. So you're putting yourself at negative 5. And at the bottom, if you're at negative 10 and then you subtract 5 more, you're going even more negative. You're at negative 15. So again, let's look at that. Is there a greatest common factor that I can divide both of those by to simplify? 5 over 5 and 15. Let's see. Well, 5 has 1 times 5. And there's nothing else for 5, right? 2 times something, no. 3 times something, no. 5 is just 1 and 5. 15 has 1 times 15, 3 times 5. And that's it. So I look, is there a common number? 1 is a common number, but 5 is also a common number. I'm going to pick 5 because it's the greater out of those two numbers, right? 5 is bigger than 1. So if I can divide both of these by 5, which is that greatest common factor, negative 5 divided by 5 is negative 1. Negative 15 divided by 5 is negative 3. And then we see, a negative over a negative, we don't want to leave it like that. A negative over a negative gives us a positive. So my answer is positive 1/3. And again, we can prove that point, right? If I wanted to draw a quick sketch of this and I graph these points, it's just estimates 5, 2. Means I'm going to go over 5 and up 2. The second point is negative 10, negative 3. So I go over negative 10 and down to negative 3. Look at that. I made 2 points. If you connect those 2 points, I'm going to do my best to draw a straight line to connect them. If you connect those points, what type of slope does that line have? It's increasing, right? It's going up. This line has a positive slope. So you have to know that your answer is a positive, and that's why our answer was positive 1/3 when we simplified. Okay, I hope that you're feeling more comfortable with this slope formula. I believe that was all of our questions here on this document. Let me go ahead and click to our next slide. That was all of our questions. We were determining slope given the 2 points. First, you have to label those points. Let me go ahead and see if I can write out some steps here for us, just so we can have those steps that we remember how to calculate slope. I would say that my first step is to label your points. Label your points, right? You have to label them with x1, y1, x2, y2. We label them with those. We have to write and substitute. Substitute into the formula. Right? That's where you are going to write out the formula. M equals y2 minus y1 over x2 minus x1. And you're going to fill in, you're going to substitute what you know into those pieces. Step 3, make it easy. You're going to do the math. Right? Straight across the top, straight across the bottom, you're going to do the math. Step 4 is, can you simplify? Sometimes you're going to see that sometimes you can't simplify. Sometimes there's not a greatest common factor, so you just have to leave it as it is, right? Negative over a negative, simplify that. If it's just a negative, you can't simplify. Step 5, I always say check your work. Not necessarily go back and check your math, but make that quick sketch of a graph and go back and see, when you graph those 2 points, is it a positive slope? Is it a negative slope? Is it a 0 slope or undefined? That will truly help you see what that slope is. Now I hope you feel a little bit more comfortable with this slope formula. There are different representations that you're going to be learning about. So we've learned about a graph and how to find slope, 2 points and how to find slope. You still have a table and an equation. So hope you got those. Continue to practice using this slope formula and always ask for help if you need it.